In 1901, a group of sponge divers exploring a shipwreck off the coast of Greece pulled something from the sea that should not have existed. At first glance, it looked like a lump of corroded bronze and stone, broken into pieces after 2,000 years underwater. But as scientists began examining it more closely, they realized this object was not art, not a weapon, and not decoration. It was a machine. And not just any machine. It was a device so advanced that nothing like it would appear again for more than 1,000 years. This object is now known as the Antikythera Mechanism, and many historians consider it the world's first computer. Built over 2,000 years ago, it was capable of predicting eclipses, tracking planetary motion, and modeling complex astronomical cycles with astonishing precision. The real mystery isn't just what it does. It's how ancient humans, using primitive tools, managed to create technology that seems centuries ahead of its time. The story begins near the Greek island of Antikythera, where sponge divers stumbled upon a Roman-era shipwreck resting on the seabed. Among statues, pottery, and coins, divers recovered several corroded bronze fragments that were initially ignored. It wasn't until years later, when archaeologists noticed strange gear-like structures embedded inside the fragments, that alarm bells went off. These were not random shapes. They were interlocking gears, finely cut, precisely aligned, and clearly intentional. X-rays later revealed that the device once contained at least 30 bronze gears, all working together inside a compact wooden casing. This was shocking. Before this discovery, historians believed that gear-based mechanical technology of this complexity did not exist until medieval Europe. Yet here it was, sitting at the bottom of the ocean, dating back to around 100 BCE. As researchers reconstructed the device digitally, its true purpose slowly became clear. The Antikythera mechanism was an astronomical calculator. By turning a hand crank, users could predict the positions of the sun, moon, and possibly even planets across time. It tracked lunar cycles, solar cycles, and eclipse patterns using advanced mathematical ratios. One of its most impressive functions was eclipse prediction. The mechanism encoded the Saros cycle, a repeating pattern that allows eclipses to be forecast decades in advance. This means ancient users could know when an eclipse would occur long before it happened. The device also accounted for irregular lunar motion, something even medieval astronomers struggled to model. This wasn't guesswork or astrology, it was precise mechanical science. What truly separates the Antikythera mechanism from everything else in the ancient world is its internal gear system. The gears were not simple. They used complex ratios to model celestial mechanics. Some gears had over 200 teeth, cut with remarkable accuracy. Even more shocking, the mechanism included a differential gear, a component not seen again until the 16th century. Differential gears allowed two inputs to rotate at different speeds, which was essential for modeling the moon's uneven orbit. This means the builders not only understood astronomy but also advanced mechanical engineering principles. They translated abstract mathematics into physical moving parts, something that would not become common again until the Industrial Revolution. This raises the obvious question: how could ancient Greeks build something like this? The answer likely lies in a lost tradition of scientific knowledge. Ancient Greece was not primitive. It was home to mathematicians, engineers, and astronomers who laid the foundations of modern science. Figures like Archimedes, Hipparchus, and Apollonius developed theories that were far ahead of their time. The Antikythera mechanism may represent the peak of a technological tradition that was later lost due to war, societal collapse, and the decline of scientific institutions. Instead of being an isolated miracle, it may be the only surviving example of a much larger body of ancient technology that simply did not survive. Most ancient technology was made from perishable materials: wood, bronze, leather, things that rarely survive thousands of years. The Antikythera mechanism survived only because it sank into the sea and was sealed away from oxygen. If this device existed, how many others were lost? How many machines, diagrams, and instruments were destroyed in fires, wars, and the collapse of civilizations? The burning of the Library of Alexandria alone may have erased centuries of accumulated knowledge. The mechanism hints at a scientific world far more advanced than the simplified version of history we are usually taught. The device wasn't just functional, it was user-friendly. Scientists discovered inscriptions etched onto the bronze plates, written in ancient Greek. These texts acted like a user manual, explaining how to operate the device and interpret its readings. This suggests it was not a one-off experiment, but a practical tool meant to be used, possibly by scholars, navigators, or educators. The level of detail implies that its creators expected others to understand and interact with it. This was technology designed to be shared, not hidden. Recent reconstructions suggest the mechanism may have also tracked the movements of visible planets: Mercury, Venus, Mars, Jupiter, and Saturn. If confirmed, this would push its sophistication even further. Modeling planetary motion requires understanding complex orbital patterns and cycles that take decades to repeat. Achieving this mechanically would require extraordinary mathematical insight. While parts of the planetary system are missing, evidence strongly suggests the builders attempted to create a complete mechanical model of the cosmos as they understood it. If ancient people could build machines like this, why didn't technology progress faster? The answer may lie in economics and social structure. Ancient societies relied heavily on manual labor, often through slavery. There was little economic incentive to develop labor-saving machines. Knowledge was also fragile, passed down through individuals rather than institutionalized systems. When key thinkers died or cities fell, entire fields of understanding vanished with them. Unlike modern science, ancient knowledge did not compound reliably over generations. Only in the last few decades have modern tools like CT scanning and computer modeling allowed scientists to fully understand the mechanism. Each technological advance reveals new layers of complexity. The more we learn, the more unbelievable it becomes. What was once thought to be an anomaly is now considered proof that ancient science was far more advanced than we imagined. The Antikythera Mechanism has forced historians to rewrite entire chapters of technological history. The Antikythera Mechanism is not just an artifact, it's a warning, a reminder that progress is not guaranteed. Entire civilizations can rise to incredible heights and then collapse, taking their knowledge with them. It challenges the idea that human advancement is a straight line. Instead, history may be full of peaks and losses, with forgotten golden ages buried beneath time. If this one machine survived, what else once existed? And what might we be capable of again? 2,000 years ago, humans built a machine that could predict the future of the sky itself. Not with magic, not with myths, but with mathematics, gears, and pure human ingenuity. The Antikythera Mechanism should not exist, yet it does. And in its corroded bronze gears, it whispers a terrifying and inspiring truth. History is not as simple as we think, and humanity may have forgotten more than it remembers.